All right, determine if the mean value theorem can be applied to f on the closed interval given. If the MVT applies, then find all the c values on the open interval such that f prime of c is equal to the average rate of change. If the MVT cannot be applied, explain why not. Ooh, what? A lot of stuff going on here. We're wanting to apply the mean value theorem. In order to apply the mean value theorem, we have to meet some conditions. We have to have continuity on the closed interval, differentiability on the open interval. Let's move on. Sine is a continuous and differentiable function. It's going to work. Let's do it. I'm giving a thumbs up and you can't even see it. See? Told you I was doing this with my other hand, but you know, this camera only captures so many angles. So pick a color. Black, yeah, that's what I'll do. Let's see. I'm going to find the average rate of change, f of pi minus f of 0 over pi minus 0, and I'm going to set it equal to the derivative, which is cosine. All right, let's find this. F of pi, let's see, sine of pi is 0. F of 0, the slope of sine of 0 is 0, and that's over pi. So we have 0. This technically is Rolle's theorem, if you want to name it after somebody. And so we're going to set cosine equal to 0, and we want to know everywhere that cosine equals 0. I'm thinking of the unit circle, which in my mind right now is purple. And so everywhere that cosine is 0, which is here, and you could say it's here, but let's be real honest, because the unit circle right now, just right now, only works from here to here, because that is our domain that we're dealing with. That's our interval from 0 to pi. So it's really a unit half circle, unit semicircle. So there, and that place there, that radian location, is pi over 2. So x equals pi over 2, and I'm right, but I'm kind of wrong. I want to be really technical about this and make sure I say it right and do it right. So this is not wrong, but find all the c values. So I'm going to get a little technical. This is technically, sorry, you can just write the final answer to be this if you want to, but what I'm really going to do is correct a couple things, and I'm going to say that the cosine of c, well, how can I do this? We'll say that the derivative at c, finding c values, which are x values, cosine of c, so c equals pi over 2. And there, I go writing it twice. I don't know why I did all that. I just wanted to use a lot of whiteout today. Mission accomplished. Okay, let's go to the next one. Is this function continuous on the interval from 0 to 1? I don't know. Yeah, it is. You don't divide by 0 anywhere in here. You never take the square root of a negative number, so you're good. Is this function differentiable? Meaning, do you ever have any jagged edges? That's kind of a bad way of wording it, but do you ever have any jagged edges? No, you don't. And actually, let me show you something about this function that's going to make this problem so much easier. This is really x to the first times x to the 1/2, x square root of x. This is really x to the 3/2. Totally legit. Like, there is nothing about this that creates a discontinuity or a non-differentiability, okay? And if you want to see it, and this is not necessarily a proof that it's differentiable, but if you want to see it, you could graph it, and you could just do, well, let's just do it the way it was written, x times the square root of x. We'll go on the window from 0 to 1, and we will adjust the window accordingly. Let me rephrase that. Once we have our x values in, and if you don't have a calculator on you right now, you can just watch. But once we have our x values in, we'll press zoom, excuse me, and I'm going to go to zoom fit, and it adjusts the y values based on the x values that we've put in. And look at that smooth curve right there. We don't have any jagged edges, so we're fine. We're good. All right, so we have continuity, we have differentiability. It's differentiable because I said so. So let's find the average rate of change. F of 1 minus f of 0 over 1 minus 0. And so 1 to the 3/2, well, 1 to whatever other than infinity, is equal to 1. And no one knows what 1 to the infinity is. It's one of those L'Hopital issues. 0 to the whatever is 0. And then 1 minus 0. So this is equal to 1. I don't know whose theorem that is. We'll just call it the mean value theorem. But then we're going to take the derivative of this. So f prime of x would be, well, 1 times 3/2, so 3/2. X to the, subtract 1 from that, that's a half. So it's really 3/2 square root of x if you want to do a rewrite. So let's find all the c values, I'll do it right this time, that equal 1. So 3/2 square root of c is equal to 1. And we will multiply by the reciprocal, so the square root of c is equal to 2/3, and we'll square both sides. So c is equal to 4/9. Done. Yay. That's the only place. Sometimes there's more than one. Okay, let's move on. F of x equals absolute value of 3x minus 9. Let's see. I wonder if it is continuous. Yes. Absolute value functions are continuous. I wonder if it's differentiable. No, they are not. However, we're actually going to be okay as long as we don't have the point of non-differentiability in that interval. So basically what I'm saying is there's absolute value. That should be a straight line, but whatever. That dot right there is not differentiable. It's not differentiable at that point. And if that point is between 0 and 6, then we would say, oh, can't do it, and we talk about why. So let's see if we can do it or not. Let's actually graph this one by hand. Let's pretend like it's calculator inactive for just a second. If I plugged in 0, plug in a 0, I'd get a 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count right? 1, 2, 3, 4, 5, 6. Woo! 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's 9. We're going to go with it. Here we go. We'll graph it in purple. And then go over to 6. 1, 2, 3, 4, 5, 6. Plug in a 6 here. We'd have 6 times 3 is 18. 18 minus 9 is, well, 9. Okay, so we've got this going on. I wonder what happens in the middle. Actually, you could figure it out. Here's a really good indicator. If you set this inside piece equal to 0 and solve it, then you would get x equals 3. So at 3, you're going to get 0. So let's just do it real quick. 3, because it's halfway in between. That's another way of looking at it, and that works in this case. 3 goes in here. You'd have 3 times 3, so 9 minus 9 is going to give me 0, and you know what absolute value looks like. And we have this. Therefore, this function is not differentiable. Continuous, yes, but not differentiable. So f is not differentiable at x equals 3. Or you could say it's not differentiable on the interval from 0 to 6. So the mean value theorem, you can abbreviate it, does not apply.